Hey y'all. Today we're going to do some operations with radical expressions. Take your sheet of paper and you can set it up like mine right here. You are more than welcome, of course, to pause the video so you can get everything written down. But if you don't get everything written down right now, I'm going to go through each section and break down each section and explain it to you. So there's three different sections. You should have an adding and subtracting section. You should have a multiplying section, and you also should have a dividing section that I forgot to label, but no problem. So this down here is going to be our dividing section. So adding and subtracting, we do those the same way. Multiplying, you do that the same way. And then dividing, you do that a little bit differently. So again, operations with radicals. We know how to simplify. We know how to do a factor tree and all that good stuff. But today I'm going to show you how to add, subtract, multiply, and divide. So I'm going to go ahead and get started on adding and subtracting. If you don't have enough space on the front side of your paper, you can just write on the back of your little chart that we're making here, or on a totally separate sheet of paper altogether. When you're adding and subtracting radicals, they have to have the same inside number. So if I'm looking at this first one here, the square root of 2 has to go with the square root of 2. And the square root of 3 has to go with the square root of 3. So think of these as like terms. So quote unquote, like terms. So square root of 2 and square root of 2 go together, and the square root of 3 and the square root of 3 go together. So when you're adding and subtracting, they have to have the same index and they have to have the same number on the inside. So my index for all of these is 2, even though I don't see it. My index is all the same, so check there. And I can put together this with this. So you just add them or subtract them together. 3 minus 8 gives me -5. And then I could put the square root of 3's together. So -4 square root of 3 is going to be matched with 7 square roots of 3. So -4 plus 7 is going to give me 3 square root 3. And this is our final answer. No different than if it was 3x minus 8x or -4y plus 7y. So we added like terms. Square roots of 2's go together, and then square roots of 3's go together. So that's all there is to it. Now we are going to look at two examples, however, where what if the inside numbers are not the same? Then we're going to want to do a factor tree like we've done before, and we're going to want to simplify our answer. So the square root of 8, I can break that down. This is 4 and 2. This is 2 and 2. So the square root of 8 is written as 2 square roots of 2. And I have this 4 that's on the outside that we can't forget about. So that 4 is going to come straight down. So now this gives me 8 square roots of 2. So again, I did a factor tree. Break your factor tree all the way down to prime numbers. Pairs go on the outside and everything else goes on the inside. Let's try 50. 50 is going to give me 10 and 5 and 5 and 2. So I can write this down as 5 square roots of 2. So the square root of 50 is written as 5 square root 2. And I have a 3 that's in the front. So 3 times 5 now gives me 15 square roots of 2. I got a plus sign in the center of my problem here. Come straight down. Now I have like terms. I broke down 8 and I broke down 50, and I now have like terms. So my final answer is 23 square root 2. So my final answer is 23 square root 2. Now, what happens if maybe we broke them down and they weren't the same? Like, what if this turned out to be a square root of 5 and this one was the square root of 2? Then you would not put those together. You would just leave them separated. But in this particular case, it did work out where they turned out to be the same. And last one for adding and subtracting, we're going to go through. We're going to do the exact same thing. We're going to break down 12. We're going to break down 27. And we're going to break down 128. So if I break down 12, that's going to be 6 and 2. If I break down 6, that's going to be 3 and 2. So the square root of 12 is 2 square roots of 3. I have a 5 that's in the front that we can't forget about. I just need to bring all the way down. So that gives me 10 square roots 3. All right, so that's the first part. We're going to go through, we're going to break down 27, same kind of fashion. 27 is 9 and 3, 3 and 3. So I can write this as 3 square roots of 3. I have a 2 that's in the front that needs to come straight down. So now I have 6 square root 3. And last but not least, we need to break down 128. 128 is a big number, lots of different things that give me 128. I am going to start with 4 and 64. No, I'm not. I'm going to start with 4 and 32. So 4 times 32 is going to give me 128. So 4 and 32. Okay, we're going to break down 32. That's 8 and 4. Break down 8. That's 4 and 2. And I got a whole bunch of 2's. Okay, so a whole bunch of 2's. You did not have to start with 4 and 32. You could have started off with a number of things. That's just what I chose to break this down into. So the square root of 128, I'm circling pairs because my index is 2. I got 2 there, I got 2 here, and I got 2 there. So this is 2 times 2 times 2. So I can write this problem as 8 square root 2. So I had a pair there, a pair there, a pair there. You multiply it, 2 times 2 times 2 is 8. And I had one leftover prime number. Now, as you can see, everything is not the same. So now my problem, if I write it all out in one line, 10 square roots of 3 plus 6 square roots of 3 minus 8 square roots of 2. So 10 square roots of 3 is what my first term simplified to. 6 square roots of 3 came from the second term. And then the square root of 128 was 8 square roots of 2. And then I brought down whatever sign was in between. Now, these two are the only like terms that I have because they're both square roots of 3. So they're the only things that go together. So my final answer is 16 square root 3 minus 8 square root 2. So final answer, 16 square root 3 minus 8 square roots of 2. All right, that is adding and subtracting. Okay, let's multiply. Okay, so multiply, hopefully you see these and you think either box method or distributive property because that's exactly what we're going to do. So I'm going to set up our box. So 6 square roots of 3 minus 5. And on the side, 2 square roots of 5 plus 4 square roots of 2. So good old-fashioned box method that we've been doing off and on throughout the semester. You put 1 on top, you put 1 on the side. Now we're going to go through and multiply what we have going on here. So we're going to go through and multiply. So hopefully you got your box set up and you're doing okay. So here we go. So I'm going to do 6 times 12. So 6 times, I already said the answer. 6 times 2 is 12. And 5 times 3 is 15. So that's the first part. Now I'm going to do negative 5 times 2 square roots of 5. So that's negative 10 square root 5. So you multiply what's on the outside and then you multiply what's on the inside. So outside with outside and inside with inside. 6 times 4 is 24. 2 times 3 is 6. So that's the square root of 6. And negative 5 times 4 square roots of 2 is negative 20 square root 2. So you multiply what's on the outside, outside with outside, inside with inside. Now, if we could factor these, we would, but none of these could be broken down. 15 is 3 and 5, but I don't have any pairs. That's 1 and 5, 1 and 2, 2 and 3. I don't have any pairs. But if I could break it down some more like I did over here, and if I had pairs of the numbers, I would break it down. But I can't, so I'm going to leave it just like this. So our final answer, we'll just write it out. 12 square roots, 12 square root 15 minus 10 square root 5 plus 24 square roots of 6 minus 20 square roots of 2 is our final answer. Ta-da! So that's our final answer. All right, let's do another box method. Same thing again. We're going to go through, we'll set up our boxes. So 7 square roots of 2 is going to go on top. And on the side, we have 7 square roots of 2 plus 3 square roots of 3. So I just went ahead and set up our box, and now we're going to go through and multiply. 7 times 7 and 2 times 2. So this gives me 49 square root 4. 7 times negative 3, 2 times 3 gives me negative 21 square root 6. 7 times 3 and 2 times 3 gives me 21 square root 6. Negative 3 times 3 and then 3 times 3 gives me negative 9 square root 9. Multiply the outside numbers and multiply the inside numbers. Outside with outside, inside with inside. Now, hopefully you see some things that cancel out. Okay. I have negative 21 square root of 6 and 21 square root of 6. These cancel each other out. So we're left with 49 square roots of 4 minus 9 square roots of 9. Now, this is a perfect square number, and this is a perfect square number. So the square root of 4 is 2. So this is 49 times 2. The square root of 9 is 3. So this is 9 times 3. So if you can break the number down, go ahead and break the number down. If not, just leave it like it is. So we need to go through. Of course, you can type this all in the calculator. So this is going to give me 98 minus 27. So our final answer should give us 71. So 71 is our final answer. I do want to make a note at this one. If I go back up to the very top, 7 square roots of 2 minus 3 square roots of 3. 7 square roots of 2 plus 3 square roots of 3. These are the exact same thing. They only differ by a sign. So one is negative and one is plus. These are actually called conjugates. And we've studied conjugates earlier in the semester when we were taking a look at imaginary numbers. So these are conjugates. What's going to happen is that when you multiply conjugates, your outside and inside are going to cancel out. So you're going to have some terms that always are going to go away. So when you multiply something that is the same, they only differ by the sign, some term in it is going to go away, which is why we were just left with a singular number for this particular problem. So this is why we only were left with 71.